Hey, I'm Scott Allen Miller, and what I'm going to be talking to you about is some context around VTL. What is it? Why is it? What does it exist? So VTL is not new, right? This has been around for a while, and but it comes from, we have a history. Backups really originated around tape, right? In the early days, 1960s, 1970s, 1980s. All we had was tape. Everyone used tape for everything. All of our backup systems were designed around tape. We have some examples here, Tivoli and DPM and Backup Exec and many things that are much older, right? They were all designed to talk to tape because it was the only thing that they had. So tape was a standard that everything was able to talk to. And for the Unix people, even tar, right, goes back to tape. It's just the standard. It's the universal thing. So tape was really, really great for backups because of the way that it worked and the expectation that you were going to take it offline, that you're going to physically put it on the site in most cases. It had high capacity compared to other storage mediums. Of course, in the very first days, we used tape as the local storage medium as well. However, over time, right, disks have come a long way. They've improved a bit. So over the years, right, inexpensive disks, as we call them, Winchester drives, have greatly increased in capacity. We're no longer talking 10 megabytes, we're talking 10 terabytes. And the cost, both overall and per gigabyte, has dropped dramatically. So the things that made tape so incredibly attractive during the years that it competed with disks have changed. Tapes have improved, but disks have improved more dramatically as a ratio during that time. In fact, disks were invented during that time, right? So the market has changed a lot, and we've seen the rise of disks. And over time, people have obviously really started to lean heavily on disks for backup and other storage media, just because it makes sense, right? They typically are pretty high speed. They have good IOPS. They aren't too expensive anymore. They're easy. People are used to them. You can have them live online all the time. You can attach them from NAS and SAN and all those things, right? They're very flexible. So during the past 20 years, we've really seen a rise of disks within the backup realm. One of the challenges that disks have had traditionally is that talking to them has been difficult, right? Because all of this software, all your backup software, some of them can talk to disks, some of them cannot. Of course, over time, more and more are starting to talk to disks. So that's become less of a problem, but it still exists that there's not a universal standard for exactly what a disk system is going to look like for backup applications. We lack the single standard that we did with tape. So this has seen some really complicated things, and we may have to maintain a special kind of SAN for certain backup. We may have to have local disks for certain backup. We may have to have a NAS. We may have to whatever. In 1997, as we said, IBM invented VTL.
IBM did not invent VTL.
Okay. IBM introduced it.
You did, right?
So VTL in the 1990s gave us the ability to talk to disks via a standard interface, which was tape. It made disks look like tape. So it's really, at a high level, it's just an encapsulation and abstraction layer, right? Make disks look like tape so that everyone else doesn't have to worry about adapting to whatever new or cool or different disk technology or non-disk, right? It could be a big memory system. I wouldn't back up to a big memory system. But if you had one, you could virtualize tape on top of it and treat it like tape and make things really easy. So we had this big movement to move to VTL, or to consider it, about 21 years ago. Now, after that point, right, we have mostly the backup vendors, started realizing that having to have a VTL layer was, not what they wanted. They wanted to talk directly to disks. They wanted to offer people, disk to tape, and they wanted to provide online automatic backup and restore. There's lots of features that they wanted to offer, and only talking to tape was pretty limiting for them. So it became very standard for backup vendors to start to talk to disk directly, which is what we would expect. Nothing weird there. And so this really kind of signaled the dusk of the VTL era. Most VTL players and products exited the market, or effectively exited the market because backing up to disks was just useful, right? So VTL kind of faded away, and we all mostly forgot about it. In the time since then, right, object storage has become popular. Object storage predates VTL. This is not a new technology, but as we all know, object storage has begun to become a very, very important player for lots of reasons, partially because major cloud providers such as Amazon and Azure and companies like that and Backblaze have really put a lot of focus on providing large-scale, low-cost object storage. And of course, on-premises players, Fujitsu, for example, EMC, whoever, have also really put a lot of effort into making big on-premises or self-hosted products. So object storage has exploded as far as availability and its cost ratios. And of course, as we start getting to really large scales, 100 terabytes and larger, companies really struggle with using anything except for object storage to really, to keep scaling and to keep their I/O going up. So this has really changed the market as far as what kind of underlying storage we're likely to want to target for everything, regardless of whether it's something you're hosting yourself or something that's running in the cloud. But object has the complication that there isn't a standard API, same as disks in the early days, right? Everyone's like, how do I talk to it? I have to have something special for every product or cloud or whoever. They may be similar. They're not complicated, but they're different. And because of the way that object works, right? Because of the way that its I/O is bound, because of where its object boundaries are, it is very difficult to present file or block storage from object. You can do it. It works just fine as a technology, right? But the underlying mechanisms of object do not translate well in an I/O way into file and block storage. So while you can do it and it physically works and devices will see it as legitimate file or NFS, iSCSI or whatever, they're not efficient because they have to break objects apart, move them in chunks, and the mechanisms that are writing to those don't understand where those boundaries are because it's been abstracted, and so they don't behave really well. It creates a lot of overhead and complication. So that's been a challenge to make object easy to consume for most products or just IT departments, right? IT departments may have their object storage. They may want to just do something simple with it, and they can't, or they can't do it effectively. So we've learned over time that tape or tape-like, before someone calls me out and says that we believe Amazon's using optical, which behaves like tape, most of the really large players, both on-premises and especially public cloud, are at the end of the day using tape or a tape-like mechanism for their cold data, because just nothing is actually that cost-effective. Once you get down to the physical layer, tape is still blowing the doors off of disks, right? It has really long longevity. It's great for cold storage. It goes offline effectively. You don't have to keep power to it. It's cost effective to keep offline for decades. And it streams at really, really high bandwidth. So tape has remained, for cost effective cold storage, really important, even if we're no longer looking at tape physically and no longer talking over a tape API, right? And obviously, hot storage, the reason this is here, hot storage on most clouds is going to be disks. Of course, it's only one tier of it is going to go to tape. So, backups. Don't we want to send backups to object storage? Object storage sounds awesome. And the answer is yes. For really small companies, sure, you can do lots of simpler things. You can talk to traditional file and block pretty effectively. But once you get to any scale, object starts becoming really, really attractive because of the cost and performance ratios. So we want to talk to object, but we have the same challenge that we had many years ago when we first started introducing tape. The backup software that we want to use to take our backups need to talk to our object storage in order to back up to it, obviously. And while many products are starting to implement some object APIs, they don't have a standard to talk to, and so each one has to be implemented individually, and this creates some complications. And as I said, right, we don't have an easy way with low overhead to turn our object into something that's already a standard API, such as file or block storage. So object storage, while possible, remains out of reach in a universal way. Right? We definitely have products, especially with AWS, that will talk to it. So you may have limited choices available to you based on the software that you have, but universally, you can't just pick any backup software, any cloud, put them, or any cloud-based object storage, and put them together knowing that it's going to work. You're going to be severely limited by one choice or the other. So what is the answer to this? Well, we know where I'm going, right? VTL, once again, comes back to do the same job that it was doing 20 years ago, 21 years ago, right? Tape is still a universal standard. Object is actually really conducive to VTL because object storage has a very similar behavior of the underlying physical media to tape, right? Non-blocking, it has huge throughput potential. It does not require high IOPS. It's not focused on random writes, right? We're doing streaming sequential writes in almost all cases. And in some cases, under the hood, we may actually have tape being the mechanism behind that object storage. So we may be, in many cases, especially something like Glacier, we may be actually looking at virtual tape on object API on tape. So tape on tape. So with this, we see the dawn of VTL again, right? We had the dark night where there was no VTL because we didn't need it. We had a moment in time where it wasn't too important. But now it's coming back as a very, very important mechanism to allow all these backup products, right, universally to have a standard API that they're able to talk to that makes sense, that doesn't have a large overhead, that mimics how object storage works from a physical standpoint, but allows us to talk to it in a universal way. So suddenly VTL, very, very useful, and we get that flexibility. Now we can use pretty much any public cloud that we want with object storage. We can use pretty much any physical on-premises or self-hosted. So one of the things that I would just want to mention about why tape is really, really nice, right? Today we have a couple new challenges beyond physical compatibility that we didn't have in the past. Of course, one of them is size. Virtual tape is nice because it gives us more flexibility in size than we've had traditionally with, traditional tapes are a set size. They are the size you bought. You can buy a couple different sizes, but you're stuck with whatever you bought. You're going to buy them in bulk. You're going to have one size to work with, right? You got 20 terabytes on a tape. You're going to be backing up in 20 terabyte chunks one way or another. With virtual tape, we get away from that, right? We have some flexibility there, and that's new and lets us go to really large sizes. We don't have to wait for, the latest LTO standard to come out before we change the size of our virtual tape.
So, I mean, how do you deal with the eventual consistency problem?
So hold that for just 1 second. I have one last thought, and then I'll hand over to Max. And the other thing is today, we are faced with ransomware as a really major threat, right? We have a new way that our backups are threatened that we have not had in the past, right? In the past, both we didn't have the mechanisms for ransomware, and obviously we didn't have the CPU power for it to be an effective attack. 3 years ago, someone attacked us, and finally our stuff's encrypted. We didn't notice for 3 years. Today, that's a really major threat and something that is really affecting people. And people who have live, online, always available, writable media for their backups are finding that they're at the same risk that their other online storage is, and they may lose their backups along with everything else. Now, of course, having fully offline backups, there's ways to mitigate that with any technology for backup medium, but tape is naturally resilient to things like ransomware. So that's a really big benefit, that by moving to the tape paradigm, whether virtual or physical, allows us to have read only, write once, read many mechanisms so that ransomware cannot attack the tapes, whether virtual or physical, which gives us an awful lot of protection so that we don't have to deal with those kinds of problems that live disk is facing. And with that, I'm going to hand over to Max, and he's going to answer your question.
Hey, Max.
Yep. So let's do the question again. So just the long-term consistency of the backups.
No, the question is eventual consistency. As you know, if we write to an object store, it doesn't necessarily have the same data in all its replicas at the same time. So if you're writing data to the object store and trying to read it back at some other place, it might have different levels or different versions of data.
So I think we'll start with the fact that it's tape, so we don't really change it that often. So it may be a challenge if you do use the block and file APIs on top of object storage. So with tape, we kind of get away from that problem as
So tape is cycled over time as you have to redo
Right.
a tape cartridge or
Right,
something.
but since
I
we're
mean,
running
it's virtual too.
Yeah,
so
it's
that's another
virtual
side
too.
of it,
So
yeah.
like by the time we cycle it, I have really high doubts that something's going to be misversioned at some point. And also,
So it's
there,
a doubt kind of thing. Is that what you're telling me?
I mean, like 10 years, we don't change like something in 10 years. And also, there are retention policies I'm going to talk about inside the demonstration session to show how this can be avoided if companies are concerned that there may be this problem of versioning.
If we're dealing with a public cloud and just sending back data to shooting data to public cloud, that's not an option because it's not an anti-tank missile. It's not like works in fire and forget mode. What you naturally do, you spawn a virtual machine in the public cloud and has access to data, and data has to be sandboxed and actually verified that the backup is consistent. Then that you can restore from the backup you did. And with this one, we absolutely have to rely on the guys who are dealing with, number one, this is a backup vendor. Number two, this is a people who are actually configuring this backup application to send data through us to a public cloud. So if they will configure sandboxing, which is available, which is available from backup vendor, then there's no issues. If it just sends the data back or forced to public cloud and see what's going to be with there, then absolutely it will be the issue what you're saying. As there's no guarantee that there will be the data consistency between the let's say the source and the destination.